Hello, welcome to this second how-to video on converting from a hexadecimal number into denary, which is how we normally consider numbers. So we're going to start off with a hexadecimal value which we need to convert into denary. What we're going to do is we're going to take it and we're first going to convert it into binary, then from binary we can figure out exactly what it is in denary. So let's start out with 2D. So the first thing which we're going to do is I'm going to consider these two, 2 and D, separately. So I'm going to put a line down the middle. Now I'm first going to look, well, what is the 2 represented in binary? Now 2 in binary is fairly simply 0, 0, 1, 0. So to convert D, I'm first going to put the placeholders for what the numbers represent above. 4, 2, and 1. And then you remember what D represents. So I'll write this down on the side. So remembering back to the previous video when I converted from binary into hexadecimal, I went through the conversion right there. So I've just written up what each of these hexadecimal values represent in denary. So as you can see, A would equal a 10, B 11, and so forth. So if we've got a D, we know that it represents 13. In order to convert that into a binary number, I'm going to first ask, okay, does 13 have an 8 in it? Yes, I can, like so. Now from 13, I'm going to take away 8. That's going to leave me with 5. I'm going to go to the next digit across, which is a 4. Does 4 go into 5? Yes, it does. Like so. I'm left with 1 remainder. I asked, does 1 go into 2? No, and I can finally put my 1 by there. So I end up with 1, 1, 0, 1. So the next thing we're going to do is I'm going to combine the 2 separate hexadecimal values together from their binary numbers. So I'm going to go 0, 0, 1, 0, 1, 1, 0, 1. And that is the number I'm going to consider, so I can get rid of the stuff above. So now that I'm considering it as one big number, I'm going to write above the placeholders for what this represents. So this first one will be 1, 2, 4, 8. The next one will be 16, then 32, then 64, then 128. Okay? So from this I can figure out what the numbers represent. So I have 132. I have 18. I have a 4, and I have a 1. What am I going to do? I'm going to add these together. So I'm going to do 32 plus 8, 8 plus 4 plus 1. That will give me a round value. If I do 32 plus 8, that's 40. 4 plus 1 equals 5. So I'm going to end up with the number 45. And that is how you convert from a hexadecimal down into denary. So 2D would be 45 represented in denary. Okay, so we have a second example here with 6B. Again, what I'm going to do is split it down the middle, like so. And I'm going to represent 6 in its binary form. So 0, there is 1, 4, there's 1, 2, like that. And B, which comes across to 11, so 8, 0, 2, and 1. Okay. So from that, I will combine the 2 numbers together to get 0, 1, 1, 0, 1, 0, 1, 1. So from that, now that I've converted these down, I will now write up the place representation for each number. So 1, 2, 4, 8, 16, 32, 64, and 124. And then I'll look at what I've got. So I've got 164, 132, 18, 1, 2, and a 1. And then what I'm going to do is I'm going to add these all together. So 64 plus 32 plus 8 plus 2 plus 1. So 64 plus 32 is 96. And then I can add the 2 to give me 98. And then add 1 to 99. And then if I add the 8 as well, that gives me 107. So therefore, 6b equals 107. So now have a go at the activities in the activity pack and then submit your answers using the form.